Machine learning is a field of artificial intelligence that enables computers to learn from and make predictions or decisions based on data. Rather than being explicitly programmed to perform a specific task, machine learning algorithms use data to identify patterns and make inferences or predictions. Machine learning can be divided into supervised and unsupervised learning. In supervised learning, the model is trained on labeled data, which means the input data is paired with the correct output, and it can be further divided into classification and regression. In classification, the model predicts categorical labels. Examples include spam detection, such as spam or not spam, image recognition, such as cat, dog, etc., and medical diagnosis, such as disease present or not. In regression, the model predicts continuous values. Examples include predicting house prices, stock prices, or temperatures. Let's practice predicting values in machine learning using the following data. This data includes wheat grain dimensions, such as grain width, length, and area, along with grain weight. I will use Python for coding the program. First, I'll convert categorical variables to numerical variables, such as 0, 1, etc. For example, I'll change CV1 to 0 and CV5 to 4 in genotype. Next, I'll distinguish from input and target data. Input data is actual data, and target data is answer. In machine learning, data is typically divided into input data, which is also called features, and target data. Input data is the actual data used to make predictions. Each input feature represents a variable that can influence the target. Target data is the answer or outcome that you want to predict. Once trained, the model can be used to make predictions on new, unseen data. In this case, I'll choose data for length and width of grains to predict grain weights. Therefore, length and width will be input data, and grain weight will be target data. Next, I'll split the dataset into training and testing sets. By training the computer, it will learn to predict values. To achieve this, I will use the following code to divide the data. I'll use different machine learning algorithms to find the most accurate model. Random forest shows the greatest accuracy, and therefore I'll choose it to predict grain weight. Now, I'll use a new dataset to compare the actual grain weight with the grain weight predicted by the random forest model. Let's believe that after processing the machine learning model last year, I harvested crops this season and measured all the data for length, width, and grain area. Then, I'll create input data for test dataset. This is because the training by random forest is done, and now we need predict grain weight about the new dataset. So the new dataset, df1, will be test data. In the previous code to split train and test dataset, I provided the test data name as test input and test target. To distinguish from this, I'll provide the test data name for a new dataset as test input 1 and test target 1. Next, let's do the same process for machine learning process to predict grain weight. But now the test dataset will be a new dataset this season. Using random forest model, when I predict grain weight for a new dataset and the accuracy is 0.84. The accuracy is decreased when I use a new dataset in this season. When a machine learning model is trained on a specific dataset, it learns patterns and relationships within that training data. However, when a new, previously unseen dataset is introduced, the model's performance often decreases. We have actual grain weight data for this season, so we can compare the actual and predicted grain weights. The test input 1 data consists of measurements I harvested this season, specifically choosing length and width to predict grain weight. I'll add this data to test input 1 with the new column name, prediction, and I'll add actual grain weight data for this season. Great. Now I have both actual and predicted grain weight data. I'll export this data to my PC. I fitted the actual grain weight, which is column C, as x-axis, and predicted grain weight, which is column D, as y-axis in Excel. The resulting figure is shown below. Let's see this linear regression is statistically significant. It's significant. Let's check R-squared. This prediction is quite accurate, showing a great R-squared value of 94.5%. Therefore, my machine learning process is quite successful. For more details, please visit agronomyforfuture.com. Thank you.